Greetings to all. Myself Murli Subramanya. So we are in unit number 1 for the subject process planning and cost estimation. So last class we discussed about process planning and what are the steps involved. So today's lecture we are going to discuss some topic related to the process selection and process planning for parts or process planning for assembly like that. So to start with, what are the factors influencing process selection? Assume like we have decided product design after discussion with that internal team based on the requirement from the customers. We have decided the product design. Then how we are going to do or what are all the consideration we should have to decide what kind of process we are going to have to make that particular product. Okay, there are various factors which are influencing the process selection. Those are listed here. One is the shape of requirement. What kind of shape we are going to make from for the final product. It depends on the design, depends on the requirement from the customer. Whether shape, what I mean is whether it is a rectangle shape or cylindrical shape or the shape with the multiple holes. So or whether the shape has some complicated structures or profiles. So depends on that, we are going to decide what kind of process we need to do. Assuming like you have a cylindrical structure, if we want to do some surface machining on the cylindrical structure or shape of the component, then we go for machining with the lathe machine. But if it is a square component or rectangular component, then we may need to go for some drilling machine or milling machine, surface milling machine kind of thing. Or we, if cylindrical component with some thickness, then we may go for gear hobbing machine. So depends on the shape requirement, we are need to choose the process. So for that shape requirement, the what kind of size or dimensional requirement. So what is the size of the component? Whether the size may be length by diameter ratio or what is the volume of the component depends on that. We may choose the machineries because the work table requirement needs to be decided. Okay, so whether heavy duty machine we need to choose or basic light duty machine is sufficient for that, or universal drilling machine we need to go. What kind of grinding machine we are grinding process we are going to do means depends on whether hand drilling is sufficient or we need to have a machine. So depends on the size of the component we need to choose the process. Then what kind of tolerance are we need? Plus or minus, whether plus or minus 0.05 or zero point 0.01 or zero point 0.2, 0.56 millimeters. Depends on the tools, sorry, tolerances required. We need to choose the machineries, tools required for that. Okay. Again, surface irregularities. What kind of surface irregularities we need? Surface finish, like what is the RA value? Because RA value represent the surface finish value. So what is the surface irregularities or surface finish we need? So depends on that we may choose some of the process. Okay, so for that also we need to have a tolerance value, surface finish value. Then how much volume are we going to make, annual volume or monthly volume? What is the production quantity required per annum or monthly requirement? So it depends on the client we have. Then we need to choose our process selection. Okay. So if we are going to make small quantity of product, then we no need to set up any bigger layout, permanent layout kind of thing. So, but if we need a mass quantity, then we need to set up our product process, so, process and layout of the machineries so that continuous production can be happening and huge number of product can be manufactured. So annual volume or production volume is much important. So that is also one of the consideration we should have. Then what kind of material characteristics? So maybe next slide I'll be discussing about factors influencing material selection, but material characteristics is very, very important. Whether are we handling like a cast iron component or mild steel component or plastic or aluminum or composite material, or are we going with some other like a clay kind of material or some rubbers? So depends on the material characteristics. What is the characteristics? What is the hardness of the material? Whether the material having the flammability, or whether the material having that brittle nature, or what is that density of the material. So many characteristics the material has, right? So each and every characteristics may be important to decide what kind of process we are going to. So these are the things very, very important for choosing the process selection. So we should have a clear idea about the product. So it's not about the alone design alone. So in design we have lots of detailing, including the shape, including the dimension, including the sizes, including that what kind of surface finish we need, and also tolerance requirement, and so how much product are we going to make, whether it's a huge volume or like a mid-level volume. So all this is much needed basic information we should have so that we can select our processes. Okay. So this is about what all the factors are influencing for material selection. So material selection in the sense basically it start with what kind of requirement for the material. What is the functional requirement of the product, particular material. So functional requirement means what are the functional requirement? Fatigue characteristics. What is the strength? What is the hardness? Whether it has a electrical or thermal properties, like whether it can. So these all the requirements are functional requirement for the particular product. So we should consider this. These are all the factors influencing our material selection. So when we are choosing some material for our product, we should have this kind of thinking. We should have an answer for that. Some material may be, some places we don't need that much hardness, that much strength. So where we no need to choose the material with the higher strength, higher hardness. Why we no need to choose higher strength or higher hardness material where it is not needed? Why? How it is affecting? So if we choose high hardness or high strength material, which is not necessary, but it will affect. If we select it, it will affect the making process or manufacturing process. We need to choose the tools and machineries to machine that accordingly. So we need to be very, very clear about what is the functional requirement of the material. Then it is linking to selection of tools, selection of machineries, selection of machining conditions, assuming like what kind of depth of cut, what kind of feed rate we can able to give, what kind of tool we are going to choose. Okay, so all these are very, very important with related to the functional requirement of the material. So we need to be very, very clear about what kind of functional requirement. Then what is the reliability of the material, what is the life of the particular material, and what is that service life durability, years of hours of operation of that particular product. Then whether the look or appearance or aesthetics, what kind of color, what kind of texture is available, whether it has irregularities or finish like a surface roughness, what kind of things is needed for the particular material, we should have that, and under which environmental condition are we working on that particular material. Okay, that is very, very important. The consider like eyes are we working, are we are working at. It's not like material alone means we need to think only about the what to say like cast iron or metals, non-metals alone. Why don't you think about dairy products like cheese or curd or jellies kind of thing? That is all very, very important, right? So ice cubes. So all are very, very important where environmental factors are very important. So under which temperature are we working? What kind of humidity are we? Or what is the corrosive behavior? So if lots of moistures or humidity is very high, And in the sense, if we are working with some of the steel material, it may get rusting or corrosive behavior may increase. So we need to control those environment so that we can able to make better components. So material selection include environmental factors, and if we are going to combine the material with other material, so what is that, like a bearing assembly? If you consider bearing assembly, it is going to have a contact between one another. Maybe it needs to be fit, whether it's a loose fit, interferent fit, different types of fit is available. You know that very well. So it depends on the fit, it may create wear and tear. So the compatibility is very, very important. Then productivity and manufacturability and cost and availability of the material. So these are all the factors we should have, we should consider when we are doing the material selection. So the first one we discussed about the process selection. Then now we are discussing about the material selection. So process planning for parts. So with that fundamentals, we should go with the next level like material selection, process selection, process selection for the parts, or process planning for the assembly we are going to discuss now. So because parts and assemblies, if you assembly in the sense what, collection of various parts or n number of products to part together comes under product, so that comes under as considered as assembly. So what are the things we need to have process planning for parts? So, which the process planning for parts involves determining the manufacturing steps. What are the sequence of manufacturing steps required to produce a given part, individual part, if you want to make? What are the manufacturing steps included? Like consider a particular component which has threading, and also it has a grooves, it has a knurling, it has a chamfering. In the sense, what are the sequence of operation we need to do? So directly we can't able to do knurling first. After that, we can't able to. We should not. We can't able to do a turning operation. So what we need to do? So if we have a cylindrical component, a whole component like 10 centimeter in length and 20 mm in terms of diameter. So if we have a step turning in this, we need to do facing in the both side. We need to do the rough turning. Then once we achieve that completed rough turning, then we need to go for the threading. In the after doing the step turning, we need to do the threading and we need to do the chamfering, and after that we can able to do the knurling. So if knurling, if we are doing, then if we are keep knurling on the one end, if you want to do, but if other end if we done the thread cutting, then we can't able to hold. So we have to do the knurling, then we can go for thread cutting. So likewise, so which operation needs to be done first? That sequence we need to decide. So that is what the process planning, because that depends on what, it's again what kind of design. So that is what I said, whether knurling is there, chamfering is there, facing is needed, step turning is needed, whether we need a grooving, depends on what kind of material we need to choose the process plan, the sequence of operation we need to, that sequence of operation if we are planning, that is what the process plan. So material selection, the product designer choose the material based on the functional requirement. We know that what are all the functional requirement. In the last slide, we discussed about the hardness, strength, durability, thermal resistance, cost, appearance, aesthetics. So kind of thing we discussed, separation finish requirement. So based on that, the product designer needs to choose the material. So most common material used in the industry are metals, non-metals and metals, plastic, composite materials, ceramics. So these are all the basic or commonly used material. The impact of material on process selection. So last slide itself we discussed about influence factors influencing the material selection. Again, I'm repeating. Once the material is selected by the product designer, it narrow down most of the suitable manufacturing process. Assume like we selected a plastic. So plastic in the sense we should not go for like a turning machine, heavy duty turning machine, and then we need to have a different process selection for plastic. So assuming like plastics in the sense we may go for injection molding or extrusion process or 3D printing. But in terms of metals in the sense we need to go for either through casting process, forging process, machining process, welding process. If it is metal joining is needed, we can go for welding process or forging or casting we can able to do. If it is a composite, so layer process or molding or filament binding process, we can go for material. So mainly if we decided the material, mostly it will give us clear idea about what kind of suitable manufacturing process we are going to have. Okay. So again, it depends on the material functional requirement we can. So this is one basic content for process selection for parts. So what is the influence of part design? So in terms of part design, multiple times I said part design includes what kind of surface finish we need, what is the dimension of the component, means the sizes, shape, what kind of tolerance requirement we need, and whether it has difficult profiles, irregularities, or complicate structures. So that is what the geometrical complexity, because it depends on that we need to choose the manufacturing process. So part design, mostly along with the materials, part design will give us better idea about what kind of process we are going to do or manufacturing sequence are we going to do. Complex geometry might require advanced technique, like basic process we can able to do in a normal machine, conventional machine. But it's a complex geometries, in the sense better we need to go with the CNC machining or additive manufacturing nowadays we can. So in CNC machining, we can able to write a code according to our requirement. Then machine tools will run according to our instruction. Then it will perform. So our additive manufacturing, we can through the additive manufacturing, we can provide the design. Then with the design, it can able to perform the 3D printing. So complex geometry means better to go with additive manufacturing. In recent development, additive manufacturing providing enormous flexibility for creating the complex geometry. So better to go with additive manufacturing or CNC machining also possible. If we are having the tight tolerances and specific surface finish, it may be needing secondary operations like a grinding or polishing needed. So part design that also influences our process selection for the particular parts. Then these are all the simple example. A typical process sequence to fabricate a discrete part. So if we have a raw material, consider, let me highlight. We have a raw material, we need to have a process, a basic process. Then if it is needed, we can do the secondary process. Then if we need, then any process enhancement like heat treatment process we need to do, we can do. Then finishing our process, we can able to send it to the company. So these are the sequence of operation. Additional secondary process sometimes required for following them. For example, if we do that heat treatment process, sometimes we need to do secondary process like the grinding and all we need to do, or polishing we need to do. Then we can go back. Then directly we can go for finishing. So basic process like a turning operation or a milling operation kind of thing assume from the raw material. Then we do the surface finishing or super finishing operation, grinding kind of thing we need to do. Once we done that, we need to enhance or strengthen the surface of the component. Then we need to do some heat treatment process. Once we done the property enhancing process, maybe some polishing process needed, means we have to come back to the secondary process, that is considered as a secondary process. Then directly without doing again one more heat treatment process, we can go to finishing operation. Then component can be sent. So that is what it is explained here. Starting the raw material, a basic process, one or more secondary operation to enhance the physical properties, finishing operation, and then finished part. This will give us complete idea about the process plan. The process plan, otherwise called as a root sheet. So consider this is the root sheet. Okay, so part number is given. So maybe I can zoom it a little bit for you guys. So this is that part number. The part name is housing valve, and two pages are there. One out of two, first slide, it is first page is given what is the size or dimension of the component, diameter and length. The diameter and length is given in terms of pipe. What kind of material is the stainless steel with the code of 416. What are the sequence of operation or number of operation they have given, like 10, 20, 30, 40. Like it depends on the company, they will be giving the number, sometimes 1, 2, 3, or sometimes 100, 200, 300, 400. If some subclasses are there, 100, 110, 120 also they will go. So here 10, 20, 30, 40, 50 given. The operation, which department they are going to do this that particular operation, under which machine, the machine numbers also given. 325 is the one labeled for particular lathe machine. Again, they are doing the again using the same machine for doing that again one more operation under the lathe machine. Then they go for drilling, they do go for milling. M is milling, D for drilling. The machine codes, it depends on the industry, they give 111, 240 for the milling, same milling machine they used for that. Then tooling and gauges, what kind of tool they use? They use a particular tool. The tool code is G857, and for other for drilling they use the tool code F511, and for milling tool they use F332. Then how much setup time? What is the cycle time they've given that particular day? So setup time in terms of hour and cycle time in terms of minutes, it's clearly given. So consider this. First one is the facing operation they are doing. After that, they are doing the rough and finishing turn they are doing. So here is the value. So 1.473 plus or minus 0.003 diameter. So they have given like plus or minus is the tolerance value of 0.003, and size is 1.47. The, again, for the diameter and for the length, how much length they need? 1.25. Length and facing should be done to what is the facing, what is the shoulder, what is the value for the facing, and the finishing turn, how much finish turn they need to do, what is the diameter of how many number of grooves, what is the depth they given. Then once we reverse, they do the again facing operation, finish turn they are doing. They, after performing that, they do the drilling operation. They are also doing the reaming operation. They do the milling operation for each, and they do the deep slot. So each and every process they clearly given the dimension values, and again the tolerance value, what kind of which department they need to do, what machine being used, what kind of tool, how much setup time needed, what kind of cycle time needed. They have clearly given in this. So this is the example for process planning for the parts. Then these are all the basic process. Some process need basic process, some process need secondary process, some component need property enhancing operation, and final finishing operation. Consider like a sand casting. Sand casting is the basic process. We, after doing the sand casting, you know the casting process need secondary operation, because the surface won't be that much smooth, because sand casting provide irregularities in the outer shell or internal. So we need secondary process. So we need machining. Then after doing machining, we are going to do the heat treating process. Then painting process, the final. But rolling sheet, after that we need to cut that as blanks, or we need to do the bending. But for sheets, no need of doing any property enhancement. Directly we can go for plating operation. Similarly, for forging, we need a machining, but no need of heat treatment process. Directly go for painting. Extrusion, we need like a cut to the particular length. The secondary process, we need to cut like a similar like a blanking. We need to cut to the different sizes, don't need a property enhancement, but we can go for anodizing process. But casting of glasses, we need a secondary process. Press or blowing process we need, but we need to have a secondary property enhancement like annealing is needed. Then chemical or etching process we can able to do. So these are all the basic process. Sometime needed property enhancement thing, sometimes not needed. Directly from secondary process we can directly jump into finishing operation like a painting, plating, or annotation, something like that. It depends on the material we have to choose. So as a product designer, we should have clear idea about the processes, the tools required, and like whether we need a secondary process, whether we need a property enhancement, what kind of finishing process, again tolerance requirement, shape require, what is the shape, what is the dimensions of the component, what are the machines available, what are the tools available in our industry, and what are how much time required to do the process, about the aesthetic, complexity of the products, everything is much needed in order to choose the process selection, material selection, and that. Okay. So I hope you guys got some fundamental understanding. So, so as we discussed about the process selection for parts, again when we are going for process planning for assembly, assembly is the collection of various parts, then we put together and assemble. So sequence of operation needs to be assembling. Again, mainly we need to think about what sequence we are going to do the assembly. Okay, we can't put and if consider the bolt and nut and washer, we can't put bolt, we can put the nut on the bolt. After that, after putting the nut, we are putting the washer is no meaning. So the sequence: bolt, insert washer, then put nut. That is the sequence, right? That sequence of operation we need to know. So process planning for assembly involves determining the sequence and methods for assembling multiple parts into final product. So we should have an assembly drawing. In that, what are the sequence of operation we are going to do, like one after another? That should be. So this is process more complex than processing planning for individual part. Yes, for individual parts in the sense machining only we need to consider what are the machining sequence we need to. But in terms of assembly, we need to be very, very careful. It is a bit complex comparing with the parts, but it's not that much complex if we are very clear about our assembly drawing. Okay. So what kind of interaction between the component, like how, like there comes your fits and limits, fits and all will come. In what way we are going to assemble, whether top-down approach or bottom-down approach kind of tool, and overall system function and what kind of functionality that particular assembly going to serve. Again, it is very, very important. You take many examples like an engine block or piston and connecting rod, or if you consider like braking system, many example you can take. It is not made up of only one part, it's a combination of parts and prepared like assembly. So we need to have a clear idea about what are the individual parts available and its functionality. Once we put it together, what the particular system going to do, that functionality we should know. So what are all the things the process planning for assembly depends on? So product design and its variety, like a specification and what kind of assembly method, what means what kind of how much volume are we going to do, and component interaction. It is very, very important because wear and tear we need to consider, like bearing. If we consider whether we are going to give some grease for lubrication, so that component interaction we should know what kind of tooling and equipment we are going to do, use it for assembly, and how we are going to maintain the quality control we should have. Okay. So what are all the things, what are the steps available for process planning for assembly? This is single station assembly or assembly line production. So it depends on the complexity of the product. We need to choose whether in one particular station itself are we going to do the assembly, or are we going to have a production line or assembly line for that. For single station, the documentation contains a list of the assembly steps in the order in which they must be accomplished. Like in one particular station, one person like a mobile phone assembly or some simple assembly, simple component with 4 or 5 components, we can stand in one place in single station, we can assemble. But the documentation should be there. First to put this one, this component A, then components B, C, D, E, or in which order it should be, like orientation, it should be assembled. Everything will be documented. So in single station itself we can able to. If the component has, the assembly has n number of components, then we need to go for assembly line production. So that assembly line production also will be concerning each and every station. Like assembly line means station 1, station 2, station 3, station 4, like n number of stations will be there. So each and every station it should be. For example, in mass production industry, we have n number of stations, but we are huge number of volume in this, and we need to equally divide and give that. So that is very, very important. Line balancing is very important. We can't overload one particular machine. So process planning for assembly line consists of line balancing, allotting work elements to particular station along the line. So consider single station, that is what I said. I'll come back to the single station later. Now I go for assembly line production in the sense line balancing only I said. So this, with this example, I want to explain the line balancing. So machine A can able to handle about 20 components or 20 pieces per hour. Okay, then we need to give only 20 for the particular machine A. So consider about machine B1 and B2. So each machine can able to do 10 in the sense we need to give equally. Okay, we can't able to overload. For example, machine B can do 10 in the sense give 10 here, give nothing, zero component to this is no meaning. So if it can maximum can handle 10 and then give 5 here, here also 5. Again, C1, C2, C3, C4 machines are there. Maximum can able to handle 5 pieces per hour. This is not necessary. Give 5 pieces to this particular machine and keep ideal for keep the machines other machines ideal. We need to equally divide and give. Then only the other machines uh, perform efficiently. Otherwise, sometimes the failure may occur. So that is what line balancing all about. Okay, so we have to be very careful about this process if we are going for assembly. Okay, so single station assembly for in the sense list of assembly step. We need to identify critical operation, what kind of tooling and equipment needed we need to, and we need to optimize the sequence, integrate the quality check. So we need to put in the quality check also inside that. Then only within a single station we can able to do the assembly. So optimizing the sequence is very important. With lots of tools are available, mathematical models and tools are available in the industry to decide which sequence of operation is optimal in terms of time saving without compromising the quality of the product and without compromising the functionality of the product. Then in terms of like assembly line process, this focus on shift to distributing the task efficiently across the multiple station to achieve balanced workload. That is very important, balanced workload. So cycle time is what? Available time divided by production volume. How much volume we are going to make and how much time we are having. Depends on that we can able to achieve the cycle time, and the number of station how we can able to decide is the total task time divided by cycle time. So with this, we can able to decide a number of stations required. So what are the steps involved? Define work element. We need to break down the sub-assemblies. Means if you're huge assembly in the sense, we need to engine, you consider engine, the engine has n number of components, right? So we need to break down into small assembly. Then whether whether it's like a independent or sequential operation or we need because sequential operation after this only we can able to perform other assembly in the sense that sequence we should have. Then calculate line requirement. How many number of line required? So number of station required based on the production rate and task time. That is what number of station. How we can able to calculate total task time divided by cycle time. Perform line balancing. We need to do the line balance as I discussed in the slide. We need to distribute the workload equal to all stations to avoid any bottleneck. So if you miss that concept, bottleneck will occur. Okay, so we need to perform the line balancing, assign resources to each station. Resources in the sense like equipment sometimes needed for assembly or tools needed for assembly or sometimes human operator needed for that particular station. That's all considered as a resources. So we need to assign uh, resources to each station, then optimize the workflow, minimize the idle time. We need to be very careful that minimizing the idle time. Idle time, if we increase the idle time means machine is not doing any such any assembly process or see any value any value addition to the particular assembly. So that considered as a ideal time. So we need to minimize that ideal time, use some techniques like that's what mathematical model or simulation techniques are available to optimize the workflow and integrate the quality and inspection also inside, because assembly line inside the assembly line itself we have to have a quality check so that we can able to do the process planning for assembly. So this is for process planning for assembly, this is for process planning for single station process planning for assembly. Then as I said, line balancing is very important. It's a production strategy that involves balancing operator. That's what human operator also considers as one of the resource, and the machine time to match the production rate to the tag time. What is the tag time? Is the rate at which parts or product must be produced in order to meet the customer demand. So we know that what is the customer demand, how when they need. With that, we can able to easily calculate what rate we need to produce the components or assembly so that we can able to meet out the customer demand. Again, I'm repeating, takt time is the rate at which, at what rate we are going to make or we are going to produce the parts or product so that we can able to meet out the customer demand. That is what the takt time. So that's what is line balancing is important. Line balancing is producing production strategy that involves balancing operator and machining time. We need to balance the operator, what are the, how many number of operators we have, what are the tools we have, how much machining time we have. We need to match that production rate according to the takt time. Takt time is what? At rate at which the parts must be produced in order to meet the customer demand. So that is what. So line balance involves organizing production activities along a manufacturing line to ensure an even distribution of workload across workstation. This minimizes idle time, increases efficiency, and ensures smooth workflow. So obviously, if we are doing the line balancing and distributing the load equally to all the workstation and distributing the operator to the all the workstation, then we can able to minimize the ideal time, we can able to increase the efficiency and also ensure smooth workflow without having any bottleneck. So this is what the picture explains. So this is the difference between process planning for single station and process planning for assembly line production, with the aspect of focus, with the aspect of scope, with the aspect of optimization, with the aspect of application. I hope you guys can able to understand. As I said, in single station, we need to have a detailed step-by-step task. But in terms of assembly, we need to efficient allocation of tasks. And yes, the entire assembly will be done at one spot itself because it's a single station. But in terms of line assembly line production, we have multiple station. What or got shared between the station, and worker movement and ergonomics very important in terms of optimization, in terms of single station, and in terms of assembly and production we need to have a line balancing and we need to plan clearly about the flow. And a single station may be useful only for the low volume and the complex product, but in terms of assembly and production we can go for high volume but standardized product. So we need to remember that if a complex product means better to assemble it in single station, but we can't able to make huge volume, we can able to only make the low volume. But in terms of high volume we need to make, then we need to go for assembly line production. But high volume means standardized parts, we need to consider about the line balancing. Okay, so with this I want to stop this today's lecture related to process planning for parts, process planning for assembly, and what are all the factors influencing the material selection, what are all the factors influencing the process selection. I hope got some understanding. So we'll see in the next lecture. Okay, thank you.